So I'm impressed that you've all made it out of bed, given that we were whiskey tasting last night. I know that certainly this has had an effect on my memory, so we'll see if I can get through the talk today. So I think I've got to start off by crediting my team, because although I'm talking about memory leaks and things, ultimately the knowledge that I've gained in how to look and cure memory leaks has really come from their hard work and the work that they do for our customers at the moment. So there's two key things that I really want to talk to you about. Firstly, memory management. So what is a memory leak, and how is it handled on our behalf, and how does that work? And then secondly, what tools do we have in order to help us solve some of the problems that you may be facing over the next coming months, years, or decades. So things like Chrome developer tools and so on and so forth, and we'll go through that. So, well, how did we get here? So why am I so interested in memory leaks? Well, there really kind of one big problem that was brought to us. We were kind of presented with a situation whereby we were told, okay, we need to make an application for the marine industry. The marine industry is quite a dangerous industry to be in, so what does that mean for us? And if you can try and imagine what it would be like if your boss or your line manager told you tomorrow, guys, we now need to make an application that will run for 8 hours without fail, without crashing at all. It has to operate, and it just has to be on a dashboard somewhere on a screen, something like that. You would think, okay, that's a bit of a problem I've got to solve, but probably something I can do, because I know I can kind of trust my browser, and I can kind of trust my coding skills to be able to get me through that, and probably the frameworks that I think I might want to use. But then your boss turns around and says, actually, no, the problem's much worse than we thought. It now needs to work for 30 days without crashing at all. So you think, oh, God, how do I do that? What does that mean? So that's a whole different set of problems. Well, we were presented with 18 months. So they came to us and said, it has to run for 18 months. It cannot stop running at all for 18 months. And we have to certify that it will run for 18 months. So it goes through a massive testing process in order to certify that this will run for 18 months. And the reason they do that is that essentially the applications that run on these sorts of vessels out in the North Sea or over in Brazil or wherever, they have divers and people working below them, and if the software fails on these things, people do die. So it's that important. Or an oil rig or something like that goes offline, and that costs £1 million+ per day for every day that they're not working. So CEOs and CFOs get quite excited about money at that point. So what have we done? Well, we've basically created, I think, probably one of the largest real-time JavaScript applications in history. I think we're definitely at well over 250,000 lines of JavaScript at the moment. And if you include all the frameworks and everything that we're using in amongst all that, there's well over 1 million lines of code in a web app, which is pretty crazy. We are pretty crazy, but it's good. And ultimately, what we're working with, we've got really complex data structure, lots and lots of information coming at us at 1 hertz. So we have an open WebSocket, and every 1 second we get new data. We effectively parse that data, display it to the user, so in some sort of nice visual representation, like what you're seeing on the screen there, and then we throw it away, and then in the next second we do exactly the same again. So the resolution is every 1 second. So that's a serious problem. And you can actually just imagine what would happen if I'm leaking 1 byte per every second that happens over the course of an 18-month period. Well, the world would blow up. So this app is split up into 45 mini MVC apps. So we have 45 packages, we call them, and they're MVC apps, each and every one of them, and they all have their own unit tests and things that go around that. And then ultimately, whenever it comes to release day or build day for us, what we do is we concatenate the efforts of all of those 45 mini apps together into one, and that produces our final output, which thankfully we only have to run on WebKit. We don't have to worry about other browsers. We've been able to specify the environment that we run it on, thankfully. So quite an interesting problem for us, and that's why I'm quite interested in this topic as a whole, as I'm sure you can imagine. But why is it important to you, and why do I think it's worth still coming along to a conference like this and talking about it? Well, ultimately, I think more and more people are looking at the web. I was debating with my colleague last night. We were questioning whether or not anybody is building desktop applications anymore at all. I wonder if any startup or any new product that's being developed just now, if anybody considers desktop as a platform to develop for, or is everybody looking at the web and web technologies and delivering things over the internet ultimately is the way? And which is why I think this conference is growing year on year. You know, this last year it was only in one room, now we're in two, and next year we'll probably have to go and use Hamden or something like that. And so ultimately we're using JavaScript as a mechanism and means to deliver that. You know, so it is becoming a problem. I know I've been building sort of single-page RIA apps for about 6-7 years now. People have been doing that a lot longer than me, and ultimately I think, though, in the last few years, the acceleration towards web and RIA-type applications seems to continue to grow. And so ultimately, you know, we're seeing that in healthcare, finance, and probably all the industries that you guys are working in as well. Over and above that, the next biggest problem is that we have this massive issue of platforms to consider. So iOS and Android pose their own problems and issues, and everyone wants something that will run on those two platforms, as well as what we used to run on our desktops, you know, and our laptops and so on. So quite an exciting topic, I think, although maybe not, I don't know. So what is a memory leak? Well, I mean, this is the Wikipedia definition, but ultimately, a memory leak is where your application doesn't return the allocated memory. So if you have 100 megabytes of memory or RAM used, and then you open a window, a pop-up window or something in your app, and that consumes another 10 meg, say, and then the user closes it, you would like to think that that 10 meg will get returned to the OS or to the platform. Sometimes that doesn't happen. You might find that all 10 meg remains consumed, or 5 meg, you know, is returned, and you've got 5 meg left or something like that. That's seen as the leak, and ultimately it's all about trying to minimize that. So what are the problems that could cause? Well, the obvious one is that you will have a diminishing performance over the course of, you know, a few hours or a few months, depending on how you're operating your application. And I'm sure you've all seen the screens on Chrome where you've had something like YouTube open for 24 hours plus, and then all of a sudden you get a big blue screen on Chrome because it's crashed, and that's probably because some video has leaked heaps of memory into that tab, and Chrome's just said, I've had enough, I'm not going to display it anymore. So you have to overcome problems like that. And obviously, the other issue is that you may end up crashing the whole PC. It is possible to, you know, consume so much memory in a browser that you know, the rest of the PC crashes, which hopefully that's never happened for any of you, but it does happen, sadly. So the big question, though, that we were asking, you know, six to 8 months ago was, well, doesn't all this get handled for us? Because surely this has been thought about by someone else, and we're just JavaScript developers, so we're very high level. We don't really need to worry about that. You know, what is C++? What's a pointer? Ugh. You know, we don't do that. And the reality is that, yes, you know, the browser is really good at handling it for us. We have a thing called mark and sweep garbage collection, and that runs automatically, periodically by the browser and the OS. That's all completely taken care of. And essentially what that's doing is it's marking the memory that has been allocated and is still allocated, and then anything that was in use, it just sweeps it up. It basically just takes care of it, and it chucks it away for us. And that's all nice and dandy, but what happens if I use a framework that's not all that good and maybe has memory leaks, which we have done in the past, and so we've got to fix that? Or what happens if there's a problem with the browser and it's maybe not collecting garbage the way we thought it would? And more likely, what happens if I'm just not very good at coding this type of application because I've never done it before, and you know, I'm coming across a problem that I've never solved, so I end up not quite architecting things quite correctly, and so all of a sudden there's a wee issue. So we have coding mishaps, and ultimately this is where you or I have failed to identify where a leak may exist in our apps. So that's kind of a bit of background into, you know, why we're interested in memory leaks, why I think it's prevalent in JavaScript coding these days, and if you're working on financial trading apps and you know, any big RIA, I think it's worth getting to know how you may want to test memory leaks. So that kind of brings us on to, well, what tools do we have? So there are heaps of tools actually to help us solve this problem, which is really handy. And by far the best ones are the ones that are provided with Chrome. Chrome developer tools have a whole bunch of task timelines and profiling tools that really, really help. However, it's not I think it's worth us not ignoring the others. So IE 11 actually has some really great tools as well. And then I've put a Photoshop logo up there. Photoshop obviously doesn't really help us with detecting memory leaks. However, there are tools for Windows, PS tools and perfmon. I couldn't find a logo for them, so I made one up, and I think it's quite nice. So they're really useful for helping you detect, well, how much is my application using? So if you've got an exe running, which might be Chrome or IE or a sort of a containerized version of that, depending on how you're doing things, then you can use some of the operating system tools to help you detect that as well. And we have to do that in our application, which is why I've also put a picture of cloud servers, because we've kind of run a virtualized environment whereby we push and deploy 30 versions of our app out every time we release, and then we run tests on that over a course of 24 hours a week, 2 weeks, a month, and so on. And that's all automated. So ultimately, it's not just doing a bit of testing on your own PC and making sure things are right. It's about trying to let it run long term and see what the effects will be. So Chrome developer tools. So I'll go into more detail on these, and then I'll kind of skip over and skip through the others, because they essentially, all the browsers do kind of the same thing. It's just that Chrome is probably a wee bit more advanced and a wee bit more well, I think the information that it provides is more useful. So there are really three key things. So if you play around in Chrome Developer Tools, you'll see this in the menus, and ultimately it's Task Manager, Timeline, and Profiles are the three main things. Your Task Manager is really the basic Task Manager, just to tell you how much each tab is using and consuming. And actually, I don't know if you're aware of this, but you can click on the column headers at the top of the screenshot there, and if you click on those, right-click on the column headers, you can actually add more columns, and there's a JavaScript memory usage header or column in there, which is quite helpful. And this is obviously great for just doing a very first preliminary round of testing. You can instantly see whether or not your app is consuming a lot more memory than you were expecting it to. So, I know what your lives are like. You probably develop the same app for a couple of days or a couple of weeks or months. So ultimately, you probably expect it to maybe consume, say, 100 meg every single time. But you've done some coding today, and then you run the app, and you decide to have a look, and then all of a sudden it's saying 250 meg, and you're like, whoa, hang on, what have I done? So this is really, really useful just to give you that quick glimpse before you go into some of the more detailed testing that you get through something like the timeline or the profile snapshots. So the timeline, though, is, again, probably, maybe I struggle to decide whether or not the timeline or the snapshot recording tools are which one is the most useful. Timeline is essentially there to help you answer the question, do I actually have a memory leak? So we use this tool to tell us that, is our app leaking memory, ? There are a couple of things. I don't know if the guys at the back can see, but on the left-hand side, there are some options around documents, nodes, and listeners, and you can essentially see the number of nodes and listeners in particular. You'll probably find that you'll only have one document or a couple, but nodes and listeners are the key things to look out for. Take for the example, you might have a table on your on view, and then you double click on a row or something like that, and then you present the user with a nice pop-up box with a form to edit something. So you're obviously going to have, say, 500 nodes, elements, DOM elements. You then do the click, then there's 750 because it's quite a decorated form, and you then hit the X or the OK button and it disappears. You'd like to think that the number of nodes goes back to 500. So those are the types of things you're looking out for there. The other thing is, and I think I thought I'd zoomed in. Okay, I haven't zoomed in. I'm really sorry. But basically, the green and blue bars that are on that chart, you're kind of looking for the memory is going up all the time as the user is interfacing or interacting with the app, which is what you would expect. And you can't expect it to just flatline all the time. So you're expecting the user to be doing stuff, therefore memory's doing all sorts of things all over the place. But the key thing that you're really looking out for are those drops. So in this screenshot, there are 2 sudden drops. And essentially, the 2 sudden drops are telling you that garbage collection has taken place. Now, you can actually run garbage collection from here as well if you want to, but I would recommend or urge you not to. You want to let the browser do that automatically for you, because ultimately, in the real world, you're not going to be able to control garbage collection. But what are you really looking for? You're looking for steady increases over time. So if you see that your chart's gradually increasing and then dropping, but it doesn't quite drop to the same level as before, then you know there may be a problem. And that's where the profile tools come in really handy as well. So on the next tab along in Chrome Developer Tools, so you've got Timeline and Profiles. The two bottom options on here are the key ones that you want to look out for. So firstly, you've got the Take Heap Snapshot option, which allows you to just take a full snapshot of all the memory that's been consumed by your tab in the browser at that moment in time. And then the second one is the Record Heap Allocations. And Record Heap Allocations is actually probably the more useful of the two. But the really great thing about this is that you can take a snapshot, do some stuff, and then take another snapshot, and then the browser has, there are options in Chrome Developer Tools to allow you to compare the two, so you can basically see whether or not memory has increased and whereabouts the memory has increased. The record heap allocations, however, and this is, I'll probably go into the next screenshot just so you can see. So record heap allocations basically does this over the course of, say, a minute or 10 minutes, however long you want to run it for. But it's got this chart at the top, and basically you can see these sort of grey bars, the kind of grey lines, and then the blue bars in that. And what you're looking for is you're obviously expecting the grey lines to appear because your user's interacting, or in my case, I'm getting data sent to my app every 1 second. So every 1 second, memory's increasing, and then we do some parsing, and then it decreases, and so on and so forth. But look what happened towards the end. There was an issue, and the blue lines have remained. And essentially, the blue lines are telling you that's where your problem is. It was at this second, at this issue, or at this point in time that we had an issue, and we didn't actually release that memory back. And so I know in my circumstance what happened was something else appeared on the screen, an error message, a pop-up box. I hit OK, and then actually I never returned that memory back to the browser. So that's or back to the OS. That's just stayed with us the whole time, that's the sort of thing that we need to look out for. So that's a really useful tool. You can see it in more detail here, actually. So you can see, where the blue bars, and then what you can do is kind of zoom in on those blue bars. So those are basically the three main tools that you use in order to help you identify memory leaks. They're not straightforward to use, and I can tell you about things like the profile and the record heap allocations tool. You'll find that there's a lot of noise in there. There's all sorts of noise, and basically because the browser is giving you the heap allocation for everything in your tab. It's everything that the browser's creating as well as all your code. So it's all about getting to know how to ignore things that it's creating. So I don't know if I've got a great screenshot. I don't think I do. If you do this yourself, though, basically underneath the constructor there, you'll see that there are some of the items are in brackets. So you've got compiled code and then array and system and so on. And then there's the next row down is object. So what you really want to do is just ignore everything that's in brackets. Everything that's in brackets is something that's been created by the browser, and we really don't have much control over it at all. So you're only really looking for the stuff that's not in brackets, and that's your own code. So then you can go and investigate deeper, and it will actually give you the IDs of the and everything to do with the DOM, and then you can see, well, actually, okay, I realise that that's the problem because that's where the allocation's been left. So, but it's difficult. I mean, you have to spend a bit of time investigating, and it takes quite a bit of learning. The other problem is that Chrome Developer Tools itself just skews memory use, because obviously Chrome Developer Tools is using quite a lot of memory anyway. So if, for me, I'm trying to guarantee to a customer that we will never use more than, say, 200 or 250 meg in this application, testing that in Chrome Developer Tools, we instantly see that it goes way beyond that, because they take up their own proportion of memory. And then we also find that there's this an observer effect as well. Garbage collection runs at unusual times. So if you've got your browser open and you've got something like Microsoft Word open, and you go between the two, you'll find that the operating system kicks in and then says, okay, you've moved to Microsoft Word, therefore this guy might never return to the browser, so let's do a garbage collection on that so that we can give all memory that we've got left to Microsoft Word, just in case he starts doing something really, really intensive over here. So the operating system is doing all sorts of things in the background as well that we can't really measure and manage so well. So it's quite difficult if you're going between, say, your own task manager or activity tools on OS X or something like that, and then you realize, oh yeah, well, it's not using as much memory as I thought it was, but the reality is it probably is, and it's just because you can't measure it correctly. So just very briefly, obviously Chrome is our browser of choice, but how do the other tools compare? Well, Internet Explorer 11 has some really great tools as well. They're very similar to Chrome developer tools now. Doesn't do quite as much, but they have they present things in more or less the same way. I think I have decided to kind of go down the copycat route, just so that makes our lives a bit easier, which I do appreciate, to be honest. Safari doesn't really do very much in the way of memory leak testing at all. So instead, what you do is you use instrument tools for Mac. If you've got something like Xcode installed, you should have these, or maybe you have them anyway, I don't know, by default on Mac. But there's an allocations option on there, so you can do that. But it's actually much lower level, and as a JavaScript developer, much harder to understand. It's easier to probably start at Chrome and then work your way down to these if you're developing for a Safari browser or something like that, or for OS X. And then FIREFOX has an About Memory tab, which is, again, very similar to Chrome's, not quite as mature, but it certainly does a good job. So the last set of tools that I want to talk about before we finish are really the ones that are available to the operating system, because ultimately it's not just about using something like Chrome and Chrome developer tools to detect what's going on. Can we do something that's a bit more low level and detect whether or not our app's actually going way off and way out? And yes, you can. Perfmon and PS tools on Windows are really useful, and what you can do is you can plot memory. You can basically take a snapshot every 1 minute, 30 seconds, 1 hour, whatever you want. You can kind of configure that, and then you can then take a snapshot, and you can end up with charts where you can pipe it out to CSV and then chart it like this in something like Excel or whatever you want. And that's really great, because you can then, with confidence, over the course of a few days, say, yeah, actually, I can see there is a gradual increase, but it's not massive. So, we're investigating something quite small. We're not investigating some massive issue. And you can see, where there's been interaction from the user and so on and so forth at that moment in time. So how do we actually go about automating this? Because ultimately we want to minimize that observer effect that I was talking about 2 seconds ago. And really, well, we basically have virtual machines that we just deploy all our apps out to. So whenever we run a build, we automatically build 30 different versions of the app in different states, and then we deploy that automatically onto an array of VMs, and it automatically triggers the memory tests and everything, which is really quite helpful. Great thing is that after 24 hours or after 48 hours, we can come back and have a look at everything in one neat place, and then just determine whether or not we've had problems. So, or even at 9 a.m., you might decide to put in a few tweaks to your code, run a build or run it against the sort of testing and the testing environment, and then by lunchtime you can actually tell whether or not your code is having a massive or no impact at all. So how would you go about doing something like this yourself, though, if you wanted to just get started? Well, really, you want to strip it back to basics. So if you have a big app, you want to take out as much as possible, and then just, in as containerized a view as possible, just take your a mini version of your app and then do testing on that, and then gradually add in bits and pieces back in. So you may have, let's just get the actual window and frame built. Then let's start adding data into it. So we've got some AJAX requests or a few WebSockets or whatever it is. You then start adding them in and see, because the chances are that's probably where you're leaking memory. And then you can gradually add in other bits and pieces like the rest of your views, your tables, whatever it might be. And then for us, what we do is we run it on as many VMs as humanly possible at any one time. So I think that's it from me. If all else fails, you can always just reload. Or you can just completely delete everything on your machine and just go to bed, which is what sometimes we want to do. So that's it. Thanks very much.